All right. This table right here, I can guarantee that you will see it again. I can guarantee you will see it again several times. But keep in mind that that's a very simple table in Word. I can move the stuff around quite simply. You know, that whole copy-paste thing just makes things so simple. For example, perpendicular bisector might be in the third slot next time. Or maybe hit in the triangle and hit outside the triangle will be switched. Okay? I want you to know the information, but this is a nice little table to organize it for you. In fact, today we will be adding a third column. We'll see if you can figure out what that column would be. Columns are the ones that go up and down, by the way. All right. So these are the four segments: perpendicular bisector, angle bisector, median, and altitude. We talked about all four. We constructed all four. And we did it on all three types of triangles. So our job here in this little organizational tool is to say what can possibly happen. Okay? And if it can possibly happen, we're going to put a check mark there. So for example, for the perpendicular bisector, was it possible that all three of them, just talking about one triangle, was it possible that all three of them could hit inside the triangle? Yep. So why don't you put the check marks where you believe they belong right now. So what do you think about all three hitting inside for a perpendicular bisector? Is that possible? Yeah, let's go take a look. Perpendicular bisector, where is it? Isn't it the first one on here? Yeah. Was it? Whoa, what is that? Go away. Was it possible for all three of them to hit inside the triangle? Yeah, it's right there, isn't it? The isosceles one? They all hit inside, didn't they? All three. So that could happen. All right. So we better put a check mark there. That could happen. Was it possible that all three hit outside the triangle for that perpendicular bisector? It was. You almost saw it just now, didn't you? Right there. If I would have just scrolled down. Oh, look at that. There it is. They are hitting each other outside the triangle. That is definitely possible. And I made you hand in your worksheet to see if you could remember. Yeah. How about angle bisector? Was it possible for all three to hit inside? Mm-hmm. In fact, if you remember the name of that one, it kind of gives that one away. If you remember the name of that point, it kind of gives that away. Is it possible for all three to hit outside? Was it possible? Angle bisector, is that next? Let's see, inside, inside, inside. Now what's that one called again? The in center. So that kind of gives away where they're going to hit each other, right? So should I put a check mark here or not? No. How about median? Did all three of them hit inside? Was that possible? Yep. How about outside? No, what's the name for centroid again? What's that point called? Oh, I told you the centroid. Well, what does the centroid do? It's a center of mass. Are you going to balance something outside the triangle? That doesn't make any sense at all. So no for the outside. And how about altitude? Could they hit inside? Yeah. How about outside? Yep, that was the one that was way out there, wasn't it? Like wasn't even close. Right? Isn't that the next one? Nope, last one. That one right there, look at that. It's hitting way outside, not even close. Okay. What I said I was going to add a column. What column could very easily be added? Yeah. On the triangle, yeah. So all three hit on. So we'll just add that one in there quick. Probably look much more official if I would have just tapped there and it would have magically appeared, but I don't have it there, so that won't work. So on the triangle. See, very clever. Just abbreviate that there. I will tell you only two of them have the possibility of actually hitting on the triangle. Which ones? Yeah. Altitude, yep, that can hit on, right? And perpendicular bisector are the two that actually can hit on. Let's think about that again. The name of that where the angle bisector comes together is the in center. And the other one's the centroid. I don't think you're going to balance something if you're hanging on to the edge of it. Right? If you're on the triangle, it's not going to balance very well for the centroid. So what is in common with the perpendicular bisector and altitude? What's one of their key words? There's one of those key words in common. And what is that key word or key idea that you had to use in both of them that allowed it to be outside or on? It's the key idea. Think same thing in common. For example, what's a similar between some of these pictures here and these pictures here? Well, the markings aren't quite on that one. I didn't put them on that one either. What marking could I say put? Right there. Or right there. Or right here. Or right there. Or right there. So what do they have in common? Right angles, perpendicular, right? So that's the easiest way to remember this little table here. Don't try and memorize the thing. See, I'm going to move it. I'm going to move the stuff where it is. So know that the perpendicular, bisector, and altitude, the two that have something to do with 90-degree angles, are the two that can have that happen. The other ones, they really can't. Okay. Or if you just remember how they're constructed, that kind of tells you too. Any questions on that? All right. These next couple, I've always thought about maybe taking these questions off, but then I have seen them on some standardized tests. So I've decided to kind of keep them on there. And that's really the only reason, because I have seen them somewhere. So we're going to state if it's always true, sometimes true, or never true. My little hint down here, it says suggestions, is try to draw a picture and show, where can it happen, and then see, does it have to happen? Okay. And what we're going to do is we're going to go back to that scan that I have there, and we're just going to use those pictures we already have. So it says right here, every point on the median to a side of a triangle. Well, let's just go see, what is that? A median to the side of a triangle. Let's go find medians on this thing. What's this one? That's not it. That's not it. Median. So let's just pick one. Let's pick a median. I'm going to say pick that one. And we're going to say that's the side that it goes to, correct? So those two blue lines are the two that we're going to talk about. On your notes, it then says that if I pick one of those, or I pick a point on there somewhere, it will be equidistant from the endpoints of that side. So let's just pick a point on there somewhere. Oh, I don't know, right about there. Do you agree these are the endpoints of the side we're talking about? Do you think that point's the same distance between those other two? If I went like this and like that, do you think they're the same distance? I see some yes and I see some no. I don't believe that they are. Are they relatively close? Yeah, they are, but I don't think they are. So that we basically are saying, well, it doesn't happen. Is there any point on this blue line right here where I would know for sure they are equidistant? There's one very specific point. Right there, right? Isn't that how you make it? So that we know is. So basically we're saying it doesn't have to happen, but it can happen. Isn't that what we're saying? So do we really have to check any of the rest of them if that's the conclusion we've come up with? It can happen, but doesn't have to. Have we pretty much come up with our answer? So do we have to look at any more triangles? No, I'm fairly convinced that the answer is what? Sometimes. Very good. I'm convinced. It can happen, but doesn't have to. All right, so this next one's talking about angle bisector. Every point on the angle bisector of a triangle is equidistant to the sides of the angle. I'll be honest, I would hope you could answer this one without looking at the picture, but we'll go take a look. So angle bisector of a triangle. Let's go take a look. Let's try the right triangle this time. That is an angle bisector, correct? These are the sides that it's bisected. That's what it's talking about there. Okay, so pick any point on there you want. Oh, I don't know, this one. That distance, remember you have to do it at a right angle in this case. What do you think? Same? What if I pick a different point? Is it still going to work? Here? See what I mean? If you understand what the angle bisector does, that kind of gives you the answer to this one, doesn't it? But let's say we're not convinced and we wanted to try another one. Let's just try this other one down here, because you got to make sure you're convinced. All right. Let's try that one, and these are the sides that create it. Of course, you would do better if you were doing it. So if I was on here somewhere, and I went there, well, this isn't a very good angle bisector, is it? Or there. Am I still on angle bisector? I think I am. There. Whoops. There. Should it be? Should it be the same based on what an angle bisector is supposed to do? Yeah, it should be the same. Okay. So, what should we answer for this one? Based on what an angle bisector is supposed to do, this is always. And we'll do one more, and I think you'll get the idea of what to do. Every point on the perpendicular bisector is equidistant from the endpoints of the segment. Perpendicular bisector, huh? That's the first one, I think. So we'll just pick one. Let's see, I don't think we've used this one yet. And we need the endpoints of this segment. And we just need to pick a point. And we'll pick that one. What do you think? It's looking pretty good, isn't it? What if I pick one out here? Should it still work technically? Whoop, go away. What if I pick way out here? Well, that one sure seems to work, doesn't it? But again, I'm not 100% convinced, so let's try another one. Let's try one over here. Let's try this one, and then these would be the segments, right? Here's the endpoints. And just pick some point. Right here. What do you think? I'm starting to get convinced. None of these are even remotely far from not working. And if you think about what a perpendicular bisector is supposed to do, isn't it supposed to hit the midpoint and then go straight up and down from there and hit it at a right angle? So don't you believe that that should be true? Yeah, I do. All right. So let's go back and answer what then, of course? Always. So look for questions like that. And I'd say draw pictures, or hopefully I'll get your assignments back to you by then so you can use those. So that was kind of the end of 5.1. We're done. Now we're on to 5.2. Rather interesting section. We could probably technically do without it. But again, I've seen some of this stuff on some tests as well. So we'll cover this just so that you have some knowledge of it when you see it. A triangle that has one right angle. That's a right triangle. I think we knew that. I think we can even all name the hypotenuse of this thing. As you look for that right angle, and across from that is the hypotenuse. Is it okay to say yx? Yes or no? Yeah, I'm not talking congruence. I'm just asking you to tell me a segment. It works. How about the legs? Well, if that's the hypotenuse, the other two are the legs. So xz and yz. Okay. Here's the interesting part. I know why they do this, but I think they could have done without it. So we'll kind of briefly go over it, and then I'll show you that you don't necessarily really need to know it this way, but be able to recognize it if you see it. I think you agree, no 4 tests right now that work for sure for proving 2 triangles congruent. And now what we're going to do is we're going to say if we know it's a right triangle, basically we know one of the angles, right? So in each one of these, we would know one of the angles because we know it's a right angle. So I would know, say, that one, I would know that one, and I would know that one. And so we know that the angle's a right angle. And so they've kind of truncated things a little bit. It kind of leans towards the laziness of math, but there's other reasons as well. But looking at these 2 triangles that we have right there, I think we all know that we can prove them congruent by side angle side. It just happens that that angle is a right angle. That's the only difference from anything we've done before. But what they say is you know what, if you know it's a right angle, just kind of forget about that angle. It's understood that we got a right angle, and all that's left is a leg congruent to a leg and another leg congruent to the other leg, correct? That's the only way to do side angle side. And so they don't call it that, they just call it leg leg. LL. If you know it's a right angle. Okay? We're leading towards something here, and once we get there, it'll all make sense. I'll tell you how I would have done it, but I wasn't asked when they were coming up with this. So either way, do you agree those triangles are congruent? That's really the key. I hope you do. Okay. So we took care of side, angle, side. Let's do another one. This is angle, side, angle. Well, kind of. Mine seems to be missing something. Mine's not angle, side, angle. How do I have to finish my angle, side, angle for it to actually be angle, side, angle? I think the marks are in yours, but yes. Yeah. Yeah, don't those two have to be congruent to actually be angle, side, angle, right? So I'm using this as a review of our other stuff as well. Well, which of those angles do they say is kind of given? Once you know it's a right angle, right triangle, you can get rid of that one and just say it's leg angle. Okay. Leg angle, not L. Okay. Really, I'm showing you this just so when you see an LA or an LL or something like that, you know what is going on, at least somewhat. This one's hypotenuse angle. Angle, side. Well, the nice thing about this one, which ones do I put on yours? Which angles? D and A again? I could do that, right? And is that still angle, side? Or could I technically do that and still have it be angle, side? Yeah, they're still congruent, right? We're so smart, we know that. But I'll mark it the way that you have it. But they're saying forget about that one again, and so they're just saying it's hypotenuse angle. Which one didn't they talk about? Of the four we know, which one didn't they convert? Side, side, side. How come they didn't convert side, side, side? I don't have an angle in it. So can I tell you it's a right angle if I don't have an angle? No, I can't. So unfortunately, side, side angle is still side, side, or side, side, side is still side, side, side. Side, side angle is the big one. I told you side, side angle doesn't necessarily work. That's because if you know the A, remember side, side angle is the bad one. If the A is a right angle, it actually does work. So if we know that, if we know that's a right angle, this works. And really, all this changing of names and stuff, that's why they changed all these names to leg, angle, hypotenuse, leg, so that they could come and just tell you this one works. So I would have just said, why don't you tell them if the angle's a right angle, side, side angle works? I think that would be just as easy, instead of giving all these different names. All right? So that's really the key. Highlight this, something like that. This works if you know it's a right angle. It gets rid of the problem with side, side angle. So now that we've done that, let's actually go try some. The best part is now that we're done with this in this section, the rest of this is easy. State the additional information needed to prove it by hypotenuse leg. So I need a hypotenuse and the leg. What did I give you? These two? Is that what I gave you? So I'll say I gave you that one in green, and in red I will mark the stuff we need to know. Huh. Hypotenuse leg. How that's that new one, huh? Side, side angle? Huh. I tricked the other class with this one. It is kind of a trick question. Does anybody believe they know the answer to this trick question? Yes. Yeah. Can we even use hypotenuse leg if we don't know it's a right triangle? No. So do we need to know that? Do I need to know that that and that are right angles? We do. There you go. There's the trick. Angle B, angle D are right angles. Is that all we need to know to use hypotenuse leg? Is that the only additional information I need? Well, do I have a leg stated congruent? Yep, check. Do I have the hypotenuse stated congruent? Do we know the hypotenuse is congruent? Because we're so clever. Because we know that that is congruent to itself. So is this truly the only thing I needed to know? If we already knew AC was congruent to itself, did we really need to mark that down? No. That's all I needed to know. So that was a trick question. So I started with the hardest one. Leg angle, what did I give you for that one? The angle, right here, N and Q. So I need leg, then angle. Again, we're saying that this is a kind of assumed. So do I have an angle marked congruent other than the right angle? Yep, check. Do I have a leg marked congruent? No. So I better state that. That is congruent to that. Now be careful. What letter is it, an R? RQ congruent to, careful, RQMN. That's all I need to know. If I knew that, we're good. What did I give you here? A couple of tick marks here. And that, I believe, huh? We need to do this one by leg. Is it okay if I just go and put a right angle on this one? Can you do that? How come I can do that? Vertical angles, very good. And so do I have the right angle? Again, we're kind of saying, yep, we need that. Do I have a leg marked congruent? Does RT and VT count as a leg? Yep. Do I have the other leg? No. So I got to state that, congruent to that. So I need to state that ST congruent to, careful, UT. Very good. See what I mean? Once you get all that other stuff out of your brain and just focus on what the words mean, it's really not that hard. But why they had to go through and make all this different nomenclature, I don't really know. Well, I do. I don't think it's necessary. Side-side angle works. That's all you need to know if it's a right angle. So we're supposed to find x. That'll actually make these congruent by the indicated theorem or postulate. So hypotenuse angle. Well, angle C and Z are definitely congruent. Angle A and X are definitely congruent, right? So basically I need to make sure that the hypotenuse of each is the same. Really, to use hypotenuse angle, right? Because we know that's congruent to that, we need that to be congruent to that, then it's hypotenuse angle. So in other words, 2x plus 10 would equal 5x minus 8. Doesn't this boil down to the same work you did in chapter 4? Really? That's just different letters. So let's subtract 2x. These are gone. 10 equals, 3x minus 8. Add 8. So I'll write it up here. 18 equals, cancel, 3x. Divide by 3. X is 6. Of course, I could have also asked for the length of AB and YX and all of that stuff. And if I did ask, and it's good to check, just put 6 in both locations and see if it comes out to the same measure. If I put 6 in here, it's 12 plus 10, 22. Do I also get 22 on the other one? Yep. Well, 5. Leg angle. Do I have the other angle marked congruent anywhere? Well, do we know another angle congruent? Yeah. Again, we're just too smart for this book. Angle. So then we need really the included leg based on the rules they've given, right? So they, based on their rules, it would have to be this one congruent to that one, which I can't do, according to their rules. I got this one right from the book. I like to just make fun of them. But would I know if I made that congruent to that, would it still have to be congruent? That would be basically angle, angle, side. Do we still know that works? Yes, we're not going to prove it that way, but we are still going to prove it. Okay? So that's another reason I don't like this, because the people writing the book don't even know it. So let's just make x plus 7 equal to 3x minus 5. It still works. Okay, right? I do that. Angle, angle, side. Let's also subtract x. 7, not an x. 7 equals 2x minus 5. Add 5. Huge coincidence here. Divide by 2. X is 6. Don't always think it's 6. It doesn't work that way. And so they should be the same. So what do I get there? 13. And here I get 18 minus 5. I got 13. Unbelievable. Again, the key here is know that they exist. Know what leg angle means. Good enough. Last one. Huh. Hypotenuse leg, that's the one that doesn't always work, right? Side angle. Well, we have the angle, it's a right angle, so we're good. So we need a hypotenuse and a leg being the same. Do I have either the hypotenuse or the leg at this point? We do or no? Yeah, which one do we know? We know the hypotenuse, right? Because that's congruent to itself. Check. Now we need a leg. This should prove it to you that it's not always 6. What has to equal what? That's a leg. That's a leg. It has to be the same. And divide by 4, of course. And there you go. If x is 9, those two triangles are congruent. What if x is something else? What can you tell me? The triangles are not congruent. Pretty much any other value? No. Because we would then not have the ever popular side-side angle. Okay. Same thing in these other ones. If they're not actually what we come up with, they don't work. Okay. So any questions on this rather interesting section that mathematicians have come up with? And again, side's not in here because, well, what are you going to do? You don't know that it's a right angle necessarily. Very colorful. And lots of arrows and circles. Any questions?